Well, hey there, kiddos. Here is your video on greatest common factor, which you should know how to do. Finding the greatest common factor of two numbers is something you probably did in elementary school, but now we're going to add variables to the mix, and it's going to change things a little. So first of all, greatest common factor, here's your definition. It is the largest number that will evenly divide a set of numbers. And when you did this back in elementary school, you probably drew factor trees and did all your primes and circled all your primes and then multiplied them back together. Well, you're not going to do it this way this time. To find GCF, and some of you will be able to do this in your head, but please bear with me and do what I'm showing you because it's going to be helpful when we get down to the factor part where we are actually going to factor two things. So number one's real easy, 16 and 24. We're just going to find the greatest common factor, which like I said, most of you can probably do in your head. But we're going to put a T under each number. And in that T, we're just going to list all of the factors of that number, starting with the first one in numerical order and going down. So the first factors would be 1 and 16. Then we would have 2 and 8. Then we would have 4 and 4. And then 4 and 4 is again the next one. You've now repeated, so we're done. Then we'll do 24 as well. So I have 1 and 24. I have 2 and 12. Then 3 and 8. 4 and 6. 5 doesn't go into 24, so we're back to 6 times 4, which we already have in the table, so we're done. So then we're just going to look at our table and pick out the largest number both tables have in common. Well, the biggest number they both have in common is this 8. So the GCF of 16 and 24 is 8. But when you get to a question like number 2, now we have numbers and we have variables and we have a positive and a negative. Well, we're going to ignore the negative only because both numbers don't have a negative. Since both of them aren't negative, then the GCF can't be negative because they don't share a negative. They don't have that in common. But we're still going to do our T. Ignore the random mark I just made. And we're going to list all of our factors, 1 and 15, 3 and 5. And then for the 20 over here, we're going to do 1 and 20, 2 and 10, 4 and 5. And then underneath each table, we're going to deal with our variables. So we have y cubed for this one. So that means y times y times y. I'm going to write it down over here. For this one, I have y squared, which is y times y. And again, go to your table, find the biggest number they have in common. It's a 5. So the greatest common factor is going to start with a 5, and then I'm going to look at my y's. This one has y times y times y. This one has y times y. Well, I'm going to circle as many as I can that they have in common until I can't circle anymore. And so what I see is that they have two y's in common, which means that they have a y squared in common because y times y makes y squared. So now let's do number 5 over here. Yes, I know I skipped number 3. We're going to do number 5 over here. Same process. You're going to draw your T, list all your factors, and then do your variables and keep them separate and in order. So I'll put my A, then my B squared, then my C, and then I will line them up over here. So I'll have my A squared, my B to the third, and my C, and we'll do the numbers first. The greatest number they have in common is the 7. And then I'm going to start with variables. A's first. I'm going to circle until I can't circle anymore. So they have one A in common. They have two B's in common, and they both have a C. So your greatest common factor is 7AB squared C. Now number 6 looks like a lot of fun because now number 6 we have 3 different things we have to do the greatest common factor for and multiple variables. But it works just like the others. So I want you to pause your video for just a second, come right back, and then check your answer and see if you get what I got. So I have my tables here, and so I've done all my stuff, and now we're just going to find what we need. The largest number they all have in common is 15, so hopefully that's what you found. Then for my r's, they all have at least 2. So I have an r squared. And if you'll notice, they don't all 3 have s's, which means no s in common, so we don't put an s. And then they share 2 t's in common, so I have t squared. So there is your greatest common factor. Now we're going to use this to do something called factor, which is the opposite of what we did in the last unit. In the last unit, we multiplied 2 polynomials together and got an answer. Now we're going to start with the answer and work backwards to figure out what were the 2 things we multiplied together. And we're going to do it using this method that I just showed you. We're going to find the greatest common factor, and then we're going to find out what is left. So for number 7 here, we've got 3 terms. We're going to do the same thing. And there are minus signs here, but there's not a negative in front of the first term, which means that our GCF is not going to be negative. It only becomes negative if every single number is negative. So we're going to ignore those minus signs, list our factors. And then we'll deal with our variables. And so we'll find the largest number they all have in common, which is this 8, even though I wrote it funny in that first one. So my greatest common factor starts with an 8. Now in your table, cross out everything that does not belong with that 8. So all of the other pairs, cross them off. Don't cross off the number that went with it. It will be important. Now we'll do our variables. They do not all have an a, so there's no a. But I can circle 1x on each one, so I have an 8x. My other factor is going to be what's left. So if you look at this first table, the number that went with the 8 is a 3. And if you'll notice, when I do 8 times 3, it makes 24, which is the number that I started with. That's what we're trying to get back to. I have 2 a's left, and I have 2 x's left. So anything that is not circled goes back into your parentheses. There was a minus sign, so put your minus sign. There was a 7 left, an a, and an x. Then there's another minus sign, and there is nothing left with letters, but if you notice, there's a 1 up here still in the table. So you've got to put the 1, you're done. Those are the 2 factors, and here's how I know. If I went back and multiplied these together using the distributive property, this right here would be the answer that I would get. So let's try number 9. Just like a minute ago, pause, do your GCF, and then come back and check your work. So I've done my tables, I've done all my variables, we're going to find the GCF. The largest number they have in common is this 5. So cross off all other pairs of numbers. So I have a 5. Then start with your a's. I can circle 2 in each one. So I have an a squared. I can circle 2 b's for each one. So that's a b squared. And I can only circle 1 c for each one. So I have a c. Now in parentheses is what is remaining. With the 5 there was a 7, but I've used everything but this b. Plus sign because that was in the problem. With the 5 there was an 8, and I have an a and a c that are not circled. Then there's a minus sign. 4 went with the 5, and I have 2 a's remaining, so that's an a squared. Those are your 2 factors. Multiply them together if you want to check and make sure, but that's how we factor using the GCF. If you have questions, you can ask them tomorrow, and I will see you then.